Okay, so you know that your blood type is inherited from your parents, and this is going to talk a little bit about how there's differences between blood types. So first, everyone starts off with the precursor molecule. It's just a few ring structures, not really important to this discussion. But then what's inherited is the glycosyl transferases. So you have one glycosyl transferase, the fucosyl transferase, and if that's all you have, then you have type O blood type with the fucosyl transferase. Now, if those add another ring, then you have terminal and acetylgalactosamine. That would be type A blood. So I think like the acetyl has an A in it, so that's the type A. If instead of the N-acetylgalactosamine, you have added a terminal galactose, that would be a type B blood. If you have both the N-acetylgalactosamine and the galactose, then you have an AB blood type. And so all of these three types have the type O blood parts, but then there's just more added on to it. You have more carbohydrates added on to the blood cell. And then you develop antigens to the type of blood that you don't have. So if you, for instance, have type A blood, you're going to develop IgM antigens against the other types of blood, so type B blood. If you have type O, you develop anti-A and B IgM. There's one really rare blood type called Bombay phenotype, and they don't even have the type O. They don't even have the fucosyl transferase, so they just have the precursor molecule. And if you test them, just like with the regular test, they're going to look like they have type O, but you need to test them even further because if you give them type O blood, they do have antigens to the type O glycosyltransferase, fucosyl transferase, and will have a reaction. So these are the carbohydrates on your blood cells, and then you also have proteins that you inherit. One really important one is the Rh protein, and they have different antigens on them. So Rh, the one that has the most antigenic effects in our bodies is the type D antigen with Rh, and there's also C and E, but they don't cause as big a reaction. So mostly we just focus on the D type of Rh when you're typing someone's blood proteins. So Rh negative patients have a reaction if you give them Rh with the D versus like the C and the E. Those don't cause a big reaction if someone's Rh negative and you give them blood with Rh protein in it. There is a phenotype that has a weak D, so not a lot of D with their protein. And so when you test it just regularly, it'll seem like they're Rh negative, but they can still have a reaction if you give them Rh positive blood. So you have to test for that weak D in order to make sure that your person getting a transfusion doesn't have a reaction. So in blood transfusion, you would increase the testing and add an anti-human globulin reagent, or AHG, and that would help test more specifically for weak Rh negative. And then there are different ways to type what kind of blood you have. There's forward and reverse. With forward blood typing, you take the patient's blood, so for instance, type A, and you add the different antigens, so the anti-A and the anti-B, into different test tubes. So you take the patient's blood cells with these antigens that you know from the lab, and whichever one clumps up, you know that's the one that they don't have. So type A blood will clump with the anti-A antigen. And then the reverse blood typing is if you take the patient's serum, which would include their antigens in it, and you add a known blood type. So if you take their antigens and they have anti-A because they're a B blood type, and you add A blood cells from the lab into it, then they're going to clump up. So that would be reverse blood typing. And and that's how you know the patient's antibodies.